We'll first define a circle. Now how do we draw a circle? We take up a fixed point and then we mark all the points that are equidistant from this fixed point. Like all these points are equidistant from the fixed point, which is the center. So I have this distance equal to this, equal to this, and when I join all these points here, I get a circle. So a circle is nothing but a collection of all points equidistant from a fixed point. So we defined a circle as a collection of points in a plane which are at a fixed distance from a fixed point in the plane. I'd like to repeat again, here is my center. I may take, say, a distance of 5 centimeters. So I will mark all points which are 5 centimeters away from this center. And the collection of all these points will make a circle. The next point is, when we draw a circle on a plane, the points in the plane get divided into 3. You have points that are in the exterior, like this, of the circle. Then you have points that are in the interior of the circle. And you have points which are on the circle. So a circle divides points into 3 parts. So circle, it divides into 3 kinds of points, which are in the exterior, which are on the circle, and which are in the interior of the circle. So here you can see points which are in the exterior, points which are on the circle, and points which are interior of the circle. Now we define the chord of a circle. To draw the chord of a circle, first we take 2 points on the circle, like A and B are 2 points on the circle, and we join this point. So this line segment is chord of the circle. Now here again we take 2 points, say P and Q, and then we join PQ, and that will be the chord of the circle. So chord of the circle is a line segment joining 2 points on the circle. Now diameter is a special chord. It's a chord that passes through the circle. Like here we can see we have AB. It is a chord, but it is a chord that passes through the center of the circle. So diameter, special chord, chord passes through the center. And another point is, remember, it is the longest chord. Diameter is the longest chord. Next we go into the arc of a circle. To draw the arc of the circle, again we take 2 points P and Q on the circle, and then the circle gets divided into 2 parts. There's one here on the top like this, PQ, which we have drawn here, and is called the major arc. And then we have another one which is PQ down, which is called the minor arc. So major arc is arc which is greater than the semicircle. So arc whose length is greater than semicircle is called major arc. And minor arc is an arc, minor arc, arc whose length is less than semicircle. Is called minor arc. Here this is major arc. Now we'll define a segment. Segment is a region enclosed by a chord. This is a chord PQ and an arc. This area enclosed between a chord, here this is a chord, and an arc is called a segment. So region enclosed between a chord and arc. Now arcs are of two kinds. We have the major arc and the minor arc. This is also an arc. Say here the chord and the segment and the arc, the chord and the arc. This is also a segment. Major segment is a segment whose region or whose area is greater than the semicircle, than area of semicircle or semicircular region. And minor arc or minor segment is the segment whose area is less than area of semicircle. So we have major segment where area is greater than semicircle, and then we have minor segment whose area is less than area of semicircle. Here this is an example of a minor segment. Area is less than semicircle, and above is the example of major segment. Next we go and see what is a sector. Now we talk about a sector. Here they have denoted a sector. You have one radius, PO is a radius, OQ is the radius, and here is the arc. This area is called the sector. So we can define sector as an area enclosed between two radii and the arc. So area enclosed between two radii and an arc. Here too we have the minor sector and the major sector. This that we had denoted was the minor sector, and it is less than the semicircle. And on the other side here we'll have the major sector, two radii and the arc. But this major sector is greater than the semicircle. So major sector, we'll write minor sector first. Minor sector, area is less than semicircle. Will be minor. And major sector, here would be area is more than semicircle, will be a major sector. The center of the circle lies in the interior of the circle. It does not lie on the circle. Let us draw it and see. Here if I have the circle, the center lies in the interior. This is the interior of the circle. Say O. This is the interior of the circle. Here is the exterior of the circle. More than the radius, you reach the exterior of the circle, and this is on the circle. So if you see the center of the circle lies in the interior inside the circle. A point whose distance from the center of the circle is greater than its radius lies in the interior of the circle. Let me draw a circle, say of radius equal to 5 centimeters. So here is a circle of radius 5 centimeters. This is the center of the circle, which means what? Every point on the circle here, these points on the circle will be at a distance of 5 centimeters. Like OA will be 5 centimeters. OB will be 5 centimeters. Now here I want a point whose distance is greater than the radius, means say its distance is 6 centimeters. I want to draw OC equal to 6 centimeters. Where will OC lie? 6 will be 5 plus 1, 6 here outside. So if OC is greater than radius, it will lie in the exterior. But if I have OC which is less than radius, it will lie inside. Suppose it is 4 centimeters, it will lie somewhere here in the interior of the circle. And if OC is equal to radius, it will lie on the circle. So here, if it is greater than the radius, it will lie in the exterior of the circle. The longest chord of the circle is dash of the circle. That we already done it earlier in the definition. This is the circle. You know what is a chord. You take 2 points on the circle and you join them and you get a chord. And you can draw so many chords. You take 2 points here, you join them, you get another chord. But which is the longest chord? If this is the center, here I am drawing the longest chord. This is the longest chord that I would be able to draw. If I join this, this is the longest chord, and the diameter. Diameter will be the longest chord. Remember, diameter is a chord because it's 2 points on the circle. So the longest chord is the diameter of the circle. An arc is a dash when it ends at the ends of the diameter. So let us draw a circle. We have to have a center. In this case, they are saying we need a diameter. So let us draw a diameter. Say this is the diameter now, AB. Now we are drawing an arc whose ends are on the diameter. So here this is the arc, but the ends are on the diameter, which means one end is here, one, and the other one is here. What kind of arc is this? You will definitely agree it is a semicircle. So an arc, when its ends are on the ends of the diameter, will be a semicircle. Segment of a circle is a region between an arc and dash of the circle. So let us draw the segment. Here we have the circle, and we know that this is the segment, this part like this. This is called segment of the circle. This region is the segment of the circle. What is it bounded by? It is bounded by a chord and a arc. Here is the chord, this is the chord, and this is the arc. A segment is bounded by a chord and a arc. So here they have already given is a segment of a circle is a region bounded by an arc and the chord of the circle. A circle divides the plane on which it lies in how many parts? So here is a circle I'm drawing. Now it divides this entire plane into 3 parts. One is the interior of the circle, then points that are in the exterior outside, and then points which are on the circle. So here you get 3 parts, 1, 2, 3. So they divide it into 3 parts. And we know which are the 3 parts: interior, on the circle, and exterior. Write true or false and give reason for your answer. The line segment joining the center to any point on the circle is called the radius. So let's draw. We have the circle. Here we have the center of the circle, and they said a line segment joining the center to any point of the circle. Center to any point of the circle, and you agree this is the radius. So this is true. Center to the circle is a radius. A circle has only finite number of equal chords. So this is a circle, and if I were to draw equal chords, I could draw one here equal of 2. So do you think that will be finite equal chords? Suppose 5 centimeter chords I want to draw. Here are the chords that I'm drawing of 5 centimeters. And you'll definitely agree they're not finite, they would be infinite. How many chords will you be drawing of the same thing? Would be infinite number. The equal chord, because you just have to take 2 points and join them, and there are infinite points in the circle. So the number of equal chords would be infinite. So this is false. If a circle is divided into 3 equal arcs, each is a major arc. First, what is a major arc? Major arc is greater than semicircle. So if I have a circle, how many semicircles can I have? I have to divide the circle into 2 parts along the diameter, and I'll have 2 semicircles, 1 semicircle here and 2 semicircles if I divide it into 2 parts. Now the same circle, they say I'm going to divide it into 3 parts. So maybe I divide it like this. I'll divide it into 3 parts, part A, B, in this manner. 1. I'll just color it. So I divide 1 arc. Then I'll take up another part, say B and C, this part, another arc, and the third. So we have 3 arcs here. We have arc 1, this is arc 2, and here is arc 3. Now to be major arc, this should be more than the semicircle. Do you think any of them is more than the semicircle? No. They are all smaller than the semicircle. Look at each one of them. Look at arc 2. It is definitely less than semicircle. Look at arc 1. It is less than semicircle. And arc 3. It is less than semicircle. So each of this is definitely less than a semicircle because they are divided into 3 parts. So here you will say if a circle is divided into 3 parts, then each is a minor arc, not major, minor arc. Means if a circle is divided into three equal arcs. Each arc is a minor arc. A chord of a circle which is twice as long as its radius is diameter. So here we have a circle, and what is the diameter? This is the center, and if I draw the diameter, see every diameter, this diameter says A and B. It is made up of here one radius and another radius. So you can say diameter equal to 2 radius, and that's exactly what they're saying. Twice radius is diameter, 2r is diameter, and it is true. 2 radii is equal to 1 diameter. Sector is a region between a chord and its corresponding arc. So let's draw this region. So I have a circle, there is a chord, so here is the chord, and this is the arc. Now what is this region called? This is not sector, this is segment. So this is false. So you will say not sector, it is segment is the region between chord and its corresponding arc. It is a segment, not the sector. Sector is this. If I draw a circle, this is sector. This is sector. It is between radius and arc. So it is between 2 radii and arc. That is sector. This is sector. A circle is a plane figure, is true. It has just got 2 dimensions, so this is true.